My name is Boaz Deco. I am co-founder of Novel Acoustics, and we do research and development in acoustics, sound technologies, sound reproduction, and we also do consulting for select clients. We're really trying to push forward the capabilities of 3D printing and find out if we can leverage these capabilities in the benefit of acoustics. There hasn't really been a product quite like this. This is, in fact, an R&D endeavor. It's sort of a proof of concept as well, sort of a technology demonstrator, if you will. We know in loudspeakers there's a lot of conflicting constraints. There's a lot of things that work against each other in order to develop a high-performance product. Acoustics are complex, and sound waves kind of behave in strange and unintuitive ways, and you really want to control and engineer this behavior in order to achieve the performance that you're after. The lattice structure that we have implemented here is a combination both of the requirement of the technology in order to print this geometry and the requirement to manipulate and sort of engineer the behavior of the acoustics inside the enclosure. So they serve a dual purpose. As you can imagine, this is a high vibration environment. Anything that isn't perfectly attached would create a noise which would become distortion when the speaker is trying to do its job and reproduce audio. So a one-piece enclosure prevents any kind of air leak, any kind of noise, all kinds of complications that can arise from poor construction. The benefits of 3D printing in terms of loudspeaker design is that it really allows you to create a single solid piece in terms of the enclosure, which is very beneficial for acoustics, as well as create these complex geometries that are not really possible to manufacture in other methods. The Stratasys Neo, being an SLA printer, really allows us to have a lot of freedom in our geometry and a lot of freedom in our design in order to achieve this kind of performance that we're after in this high-end speaker demonstration. You can really engineer different regions of the structure to be more rigid or more flexible or reinforce one part more than another and really control that to a much finer resolution. And the surface quality finish that comes out from this printer is really impressive, and the rigidity of the parts and the materials that we're able to use. Having the enclosure made of watershed allows it to be clearly transparent, and we can see what we've done and we can see any defects that could occur. The Perform material, the cream ceramic composite material, is very rigid. It's very strong. It's very good in terms of its mechanical properties, and that's very important for a loudspeaker to be a very solid and rigid structure. We wanted to focus on the unknown, which is the enclosure, and work with something that would be reliable and would be predictable in how it performs and how it behaves. It was very, very natural for me to bring Morel into this project. Morel drivers, and in particular the ones we're going for here, are consistently reliable and very, very well engineered, and the performance is just outstanding.
We manufacture, design, and develop those drive units that are in that beautiful speaker that is 3D printed here in Stratasys. The drive units are our made drive units. And this is the outcome, which is actually beautiful and acoustically a very correct product. This is the future of speakers.